There is a typical problem on limit. We have to determine this limit m by 1 minus x to the power of m minus n by 1 minus x to the power of n while x approaches 1. If we examine the limit carefully, it is infinity minus infinity type indeterminate form. So we may apply L'Hopital's rule. But before applying the rule, we would just simplify it to 0 by 0 type indeterminate form. Now we know that 1 minus x to the power of m is equal to 1 minus x times x to the power of m minus 1 plus x to the power of m minus 2, carrying on like this up to 1. When x approaches 1, each term of the series become equal to 1, and since there are m terms in the series, the value of the limit of the series as x approaches 1 is equal to m. So we get m divided by this thing over here, and similarly over here it become n divided by this thing. Further simplification leads to this. Remember that the value of this series is equal to m, and this one is equal to n due to the same reasoning. So the limit of the numerator approaches 0. The limit of the denominator also approaches 0. So this indeterminate form is 0 by 0 type. We may apply L'Hopital's rule now. Now put this thing as u and this thing as v, such that du by dx is equal to differentiation of all these terms, which is equal to m minus 1 times x to the power of m minus 2 plus m minus 2 times x to the power of m minus 3, carrying on like this up to 1. Similarly, dv by dx is this. Differentiating the numerator, we get minus m by u squared du dx plus n by v squared dv dx. Differentiating the denominator, we get minus 1. Simplifying, we get m times this thing divided by square of this whole thing minus n times this thing divided by the square of this thing. Now when x approaches 1, this thing become sum of this series, and this one become m square. Similarly, this thing becomes sum of this series divided by n squared. Now we know that sum of this series is equal to m times m minus 1 divided by 2. Similarly, sum of this series is equal to n times n minus 1 divided by 2. Simplifying further, we get the value of the limit equal to m minus n divided by 2. Now sometimes this limit is asked by the examiner to solve without taking the help of the L'Hopital's rule. In that case, we first get m times 1 minus x to the power of n minus n times 1 minus x to the power of m divided by this. Now we apply the formula we have already learned, that is 1 minus x to the power of m is equal to 1 minus x times x to the power of m minus 1 plus x to the power of m minus 2, carrying on like this up to 1. We also apply the same formula over here and we get this. In the denominator, we get 1 minus x whole square times x to the power m minus 1 plus x to the power m minus 2 up to 1 times x to the power n minus 1 plus x to the power n minus 2 up to 1. From here, we take 1 minus x common and we get this. We ultimately get this after cancelling out 1 minus x. Now we express this term as product of these two terms and evaluate the limits separately. This one become n and this one become n as x approaches 1. So the value of this limit is 1 by mn. Now we take this as function fx. Now we know that when x is equal to 1, this thing become equal to m and this thing become equal to n. So f1 is equal to 0. So this limit is actually fx minus f1 divided by x minus 1. Of course, this minus 1 has been taken out because we have written x minus 1 instead of 1 minus x. Now, by the knowledge of differentiation, this is nothing but equal to minus f prime 1. Now, first we have to determine f prime x. That is, we have to differentiate it, which is equal to m times n minus 1 into x to the power of n minus 2 plus n minus 2 into x to the power of n minus 3 plus carrying on like this up to 1 minus n times m minus 1 into x to the power of m minus 2 plus m minus 2 into x to the power of m minus 3 plus carrying on like this up to 1. So f prime 1 is equal to m times this series minus n times this series. The sum of this series is equal to n minus 1 times n divided by 2, and the sum of this series is equal to m minus 1 times m by 2. We simplify and we get the same result. Now this limit is sometimes taken as a standard limit and is used to solve other problems. We are given this problem. How to solve this one by the knowledge of this standard limit. First, take out 5 to the power of m common from this denominator and also take out 5 to the power of n from this denominator. This 5 to the power of m minus 1 can also be written as 5 to the power of m divided by 5. Also, this 5 to the power of n minus 1 can be written as 5 to the power of n divided by 5. We can now cancel out these terms. Now put 4 plus x divided by 5 equal to z, such that as x approaches 1, z also approaches 1. So the limit is simplified. The 1 by 5 comes out, and we have simply to find out this limit m by 1 minus z to the power of m minus n by 1 minus z to the power of n as z approaches 1. Now, putting the value of this limit from the knowledge of the standard limit, we get the answer, which is m minus n divided by 10.